Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to be looking at synchronous counters, and specifically we're going to look at synchronous counting with JK flip-flops. Now in synchronous counting we're going to send the clock to all the flip-flops at the same time. So the thing we have control over in this is what the inputs to the JK flip-flops are. We're going to see that we're going to need either to remain the same value or toggle that value, and the JK flip-flop is really good for that since it has both of those operations available to it. We're going to look at both the up count and the down count and the difference between those, and take a look at a simulation of one of those at the end on Multisim Live. Alright, let's get started. So we have synchronous counters. With JK flip-flops. Okay, so we said we need toggle and we need no change, and so let's take a look at what a JK counter, JK flip-flop looks like for that. So if I have JK have both inputs at 0, this is no change. Okay, so both inputs are the same, that's notable. And if I have JK where both inputs are 1, this is toggle, and again both inputs are the same. So essentially we're going to feed both inputs of the JK either 0, meaning that it won't change, or we feed it 1, meaning that it will toggle. So then the question is, when should you not change, when should you toggle? So I have a truth table over here which is a count, and so it's a 4-bit count going from 0 to 15 here, okay? And so I want to look at when do we change each of the bits. So for A0, we toggle every time. So no matter what you are, you're going to toggle. Okay, so if you're 0, you toggle. If you're 1, you toggle. That's how it goes. So let's go ahead and start to build this guy over here on the right. So if I have my JK flip-flop, my clock, my Q bar. Okay, so I'm going to have my clock coming in. I forgot the L. Do I need it? Yes, I do. Yes, I do. I know some of you understand. Okay, so there's a clock. We also need to feed a 1, 1 no matter what to J and K, so we'll do that by doing a constant, feeding that 1 into J and K. Awesome, we got our first bit, A0. Okay, what about the next bit? Well, the next bit alternates, let's see, let's get a different color here, we'll go a little blue. Alternates here, it alternates here, it's basically every 2, right? And so what is the state of the bits when we toggle A1? And what we'll notice here is that when we toggle A1, A0 is 1. And when we don't toggle A1, A0 is 0. Now, this makes sense, and I'll show you why. You understand this already by looking at counting in base 10. In decimals, right? So if I'm counting in the ones place, and I start at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When do I change the next place, the tens place? When the count in the ones place is 9, when it's at its largest value. So we keep it the same, the 10 is at place is 0 until we get to 9, and then once we finish with that 9, when we flip, then we put a 1 in the tens place. And then the same thing happens the next time through, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the ones place is a 9, it's the largest possible value, and then when we increment 1 more, we have to toggle or add 1 to the tens place. Now if we look at the hundreds place, it's the same thing, right? 97, 98, 99, and then 100. In this case, not only is the ones a 9, but the tens place is a 9. They're both at their highest value, 99. And that logic will be what we're using to build our synchronous counter right here. So when our A0 is at its highest binary number, which is a 1, then we should toggle the A1 bit, okay? So toggle means that JK both gets a 1, and so that means we can actually use the output A0 as a 1, and when it's a 1, we'll toggle, and when it's a 0, we'll no change. And so it looks like this. I got J, K, Q, I did that again, Q bar. Okay, great. Okay, J, Q, yay. And then here's our clock. So our clock is the same clock, so go ahead and connect the clock. But now we're going to put our inputs J and K, we're going to put them in from the output of A0. And so this is J and K, okay? And so what we've done here now is, this is when A0 is 1, we toggle A1, okay? So this is A0, this is A1, right? By the way, I haven't mentioned this, but this is for an up count. Hopefully it was pretty obvious, this is an up count, okay? Let's look at the next one though. So by our logic, when the first two bits, A0 and A1, are at their highest value, we should then toggle the next bit, A2. And so let's look at when A2 toggles. Indeed, it toggles here and toggles here. What are the state of the bits before that? 1, 1, and 1, 1. Okay, so that's exactly what we expect. But now we have to take care of the fact that we need both A1 and A0 to be a 1. And so when we feed JK, it's not just from Q of A1, it's Q of A1 and A0. So Q of A0 and Q of A1, when they're both 1, then we should toggle A2. We also want to give it the same exact clock. So there's Q bar. Okay, so this is A2, and then this AND gate says that A1 and A0 are equal to 1. And so when that's true, we toggle A2. Okay. I think you can see the pattern here, but let's just finish it off. So when do I toggle A3? Right here. And what is the state of the bits? When I do that, all previous bits are 1. So we just kind of propagate and add on to each of these. So right now I have this AND gate, which is A1 and A0. So I'm going to AND the output of that AND gate with Q of A2. So we'll just go ahead and put another AND gate here. And there are always two inputs, the previous AND gate and then the new output from the last flip-flop. Okay, and then this AND gate is when A2, A1, and A0 equal to 1. And if that's the case, we toggle A3. Okay, so that is the entirety of this, and you can continue to go to A4, A5, A6, and so on. But that's how we build a synchronous up counter with JK flip-flops. Let's take a look at the down counter. So the down counter works fairly similarly. There's only one difference, and that's the fact that we don't flip on 1s, we flip on 0s. Now let's make sense of this. Let's do our count in decimal. If I'm at 105, go to 104, 103, 102, 101, 100. And at 100, when both the 10s and the 1s are 0, the next number is 99, means that we toggled the third place, right? We call that maybe A2 or D2, whatever you want to call that, right? We had to toggle that from 100 from a 1 in the hundreds place to a 0 in the hundreds place. And that's the same thing that's happening here in our down count. So here's our down count for binary. Okay. When B0 is 0, we toggle, right? When B0 and B1 are 0, we toggle B2. When B2, B1, and B0 are 0, we toggle B3. And so that's the way it's put together. how do we implement this? Well, we want to toggle not when they're ones, but when they're zeros. And the way we can get a zero, use a zero as a toggle, is take from Q bar, right? So when this whole flip-flop is a state of zero, when Q is zero, Q bar is one. And so we can take that one and make JK flip-flop, or JK toggle here, okay? And then again, similarly, we'll take Q from the next one, we'll AND it, just like we did in the up count, and then we'll feed that to the JK on the next one, and then so on and so forth as we go along. So the only difference, and we still actually put a 1 into here because we want this to flip-flop every time, and the clock is the same for each. So the only difference is that we pull from Q bar. Instead of Q. Okay? So I'm going to leave it short like that. So if you have any questions, feel free to leave them in the comments, but hopefully that makes sense from our previous discussion on the up count. And now I'd like to go to Multisim Live and build one of these. Let's build the down count, I think. All right, so I need some JK flip-flops, and they are right here. JK. JK. All right, duplicate, duplicate. Okay, that looks good. I need a digital 1 up here for the first set of JKs. Let's do it right there. Awesome. And now we need to pull this Q, and that will feed the second set of second JK. And now I need an AND gate, and that's an AND 2. We'll rotate that, bring it down. Okay, you know what? We'll rotate it again. I'm just going to do this. All right, perfect. And so then this will connect to, this is Q0, and now I'll take, oh, wait, we're going to do a down count. We're going to do a down count. So I want Q0 bar, and then Q0 bar here. Great. And that will feed our JK. And then I want another AND gate. And we'll take from Q0, or Q, sorry, Q, this is now Q1, Q2 bar. And that will feed in like that. Oh, that looks good. Perfect. Okay. And so now we need a digital clock. I'm going to change this to about 10 hertz. It's not exactly 10 hertz because there's something that happens here with the simulation, but it'll serve. All the clocks are the same, they all go to the same spot. Okay, and now let's display this on a hex display. Now we take Qs because Q is the state of the flip-flop. We won't touch the asynchronous inputs, we'll leave those just as they are. Okay, I think we have everything we need here. Let's go ahead and, oh, I do want to change this. I found that this orange color is really good. Okay, so let's see what happens here. F, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yes, we have a synchronous down counter. Okay, that's what we were looking to achieve, and there we have it. So, reminder that we're pulling from Q bar into each of these, and that makes it a down counter. You know what? Why not make the up counter too? I mean, it's really that simple. If we just get rid of the Q bars, turn this into an up counter by connecting now the Q. Oh, I do have to use some junctions to do it since we already have it wired up, but that's okay. You just go here and grab a junction, wire it up, and then grab a junction, wire it up. And how many seconds did that take? Like 10 seconds? And now we have an up counter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all I did was tell the flip-flops when they should flip-flop. Should you flip-flop on zeros or should you flip-flop on ones? And making that change it from a down counter to an up counter. All right, great. Thanks a lot for watching. Always appreciate your time and hope this had value for you. I'm Mike Stanzik from Digital Electronics Classroom. Please like and subscribe. And as always, have a wonderful day.